Alright, this is going to be a quicker video than I thought, sorry, because there's not much time left on the camera because I forgot to transfer the things off. But anyway, we're going to do, trying to get more electronics videos done, not being very successful. So tonight we're just going to look at something, which I hope to use for some things. I don't think it's going to really work on this kind of video format, but anyway, it's a suitcase. It's way too big for the shop. So what's in the suitcase? I'll turn it around. Probably going to take what's in the suitcase out of the suitcase because it's a bit silly, but it does come in the suitcase. I have to kind of work out how to open it. I can't even get it to open under the camera. So, put that there. And it is this. So this looks pretty exciting if you ask me. It just fits in the camera. So I'm going to take it out of the box actually. So it goes in here. It belongs in the suitcase, but you can take it out. And that's what it looks like. It comes with a whole pile of jumper wires. So it's just a little breadboard, but it has some neat little extra features. In fact, it has lots of extra features. And it has a power cord and everything. And this thing here, I don't know what that thing's actually for, even if it is meant to go with it. And we've got that, an edge plate, these things here, a little bag of this. I wonder how old this thing is. And there's even a manual, and look, there's even a spare one of these. That's quite nice. So I don't know if that actually came with it originally. So I bought the second hand, obviously. I don't think this has been sold for quite a long time. So just move some of the things off to the side. So this is what it is. It's a digital training system, the model ETS-5000. User manual and practice. So that's quite neat. It's got lots of interesting things, I'm sure, but I'm not actually going to go through. Is it actually telling you what's on the inside? I guess it is. But we'll just have a play around with it and see what happens. I've never turned this on, so it might not even work, in which case that would be a bit sad. But it could make making little experiments and doing things a bit easier and faster. This is an interesting little device. It's never been opened. I don't know if that actually came with it. It says your combination lock is set. This is a little piece of paper. It says about the combination. So it actually comes with a little combination lock on the front of the suitcase. It's a real suitcase. Okay, so I'm going to plug this in to, I'm not actually sure where is the best place. I think that works. Well, it's on now, so the light comes on. So that's something. You can't even see the light. There's a little light switch, and there's the title over the top. But I'm going to bring it back down to here. And so basically, yes, you've got like power coming out of here. You've got a whole bunch of switches at the bottom, 8-bit data switches, and then there's you can see there's a little little display down there, and there's some more displays over here. So I think these are probably linked up to something similar to those 4511s I did in the last video. We might even just see if we can find this out. And the really cool thing about this is that it supplies, oh, you can kind of hear a high-pitched sound. Or maybe it's just my imagination. Voltage, so you can adjust these things? What was that? Is that weird? I feel like I should turn it off first before I do anything silly. So this allows you, this is a variable power supply, and you can have a negative and a positive from the ground. So this should make playing with op amps a piece of cake. So we're going to use, we've got a whole pile of these things here, and I feel like I should at least vaguely try and get colors that make sense. So I'm going to put that one in there, and these are nice quality little breadboards. They've even got little contours in them, specifically for this sort of rounded end thing. So I'm going to put 5 volts. We'll just start off with 5 volts going into the power thing. Okay, it goes in. I guess we should try turning on. Look, you even get, wow, is that the 5 volts? There's so many things to look at and play around with. It's got a pulse generator, and it's got TTL or CMOS, and a little thing to change the frequency and amplitude. Oh my goodness! Look at this. You can change which you working with CMOS or TTL. 8-bit LED display. So apparently one of these LEDs doesn't work. You can't see that. There's a bunch of LEDs at the top over there. So we could in fact just try turning on one of the LEDs. Well, we'll try it. First off, we'll do this little LED. I need some random resistor. This one's pretty random. It's a bit too high up, but hey, that's alright. And so we'll just put U. So we should actually see if the negative 5 volts works. Well, I could just use a multimeter, couldn't I? Well, we can do that. Alright. We will in a second. First off, we're going to make the LED turn on and see if that works. And it does. I want to see what this probe does. I want to see what the value means. Alright, where do the probes go? Is it just going to tell you a very, very rough voltage level between and with a 1-digit voltmeter? We'll plug this in. Oh, it says P now. So what if I touch this to here? It says H. It says high. Oh, it's telling you if it's high or low. So if I touch it down here, it should say low. It does. Look at that. Can you see that? Is that even showing up? I think it is. So it doesn't tell you the volt. It just tells you the logic level. High, memory no, input. So if I take this TTL levels, it might not. That doesn't work now. Woo! High, low. Well, that's kind of cool. I'll put that to the side for now, and then we can turn this. Well, we can change this around. So if I put this onto the minus 5 volts, it should not work. But if I turn the LED around, it does work. So yay! So we're going to put 5 volts into here, and then we're going to actually test that we are getting. So between the minus 5 volts and the plus 5 volts, we should get, of course, 10 volts. So I'll get out my not so great little dinky little multimeter. I was playing around with some other stuff with transistors yesterday because I am going to try this a transistor in there, and I am going to talk about transistors very soon, I hope. I'm just really trying to make sure that I understand it absolutely 100% before I try and explain it to anybody else. And there's a few things that are confusing me, but anyway, the point was, what was the point? Oh yes, that I wonder if this is that accurate. Like, it's sometimes a bit off. Well, it could be a bit off. It could just be me misunderstanding what's going on. But anyway, let's just see this. It's probably saying, it says, whoa, look at that. It's dead on 10 volts. I've got this the wrong way around, but you know what I mean. So it's 10 volts. So that does kind of work. That's cool. So that's what I like about this. Is it's going to be heaps of fun. Just for getting into doing op-amp stuff without having to worry about the single supply, because I keep wanting to do everything with a single supply. We're going to talk about that if you don't know anything about op-amps, but it just makes all the introduction circuits much easier to understand and work with. So that will be fun, and we're going to try this thing before we finish it off. I've only got 7 minutes left, so this was going to be just a quick video. I was actually wanting to really talk about these things, which I got a bunch of. Actually got tons of different types of LED display things, but these ones I bought randomly off second hand. Though some of them, like these ones, they've got little bits of solder on them, so they've been desoldered. But I'm hoping they still fit in fine with the... It's going to be hard to fit them into here. I don't know how they're going to work. They're going to have to... How am I going to test this thing? I'm going to have to do it like that. It's going to have to go across a whole bunch. It kind of goes in. Am I breaking it? I'm breaking it. Oh, I see what's happening. Man, these are going to be tricky to work out. Because there doesn't seem to be actually any way I can put them on these breadboards in such a way that I can actually... I may have to just do it the other way with the other kind of But anyway, we weren't here to talk about this, but we are going to do those because I'm going to make myself a little Tetris game. Because I've never written a Tetris game, and as a computer programmer of many years, it seems a little bit bizarre. But I want to build it, and we're going to go through, and we're going to build the controller chips for that. But anyway, let's get these things just to work, because I want to see if they really do. They don't come on, so I don't know. I feel like maybe I should be putting these through some kind of resistor, because I don't know how it works. I don't know how to turn it on. I'll make sure that's on CMOS. These are 33. I don't want to open those up. We'll just use some more of these. These are way too high. Alright. So if I just... Well, these are actually quite long wires, aren't they? I'm suspecting that these boards do in fact split, because you can see because they've got the little lines, so that these ones, this one isn't actually connected up to the power yet. They're not coming on. It's not working, is it? Is there a switch I have to push? There probably is a switch. Oh, these are different lengths. Oh, right. They're like those random ones you get in those sort of introductory kits that are all different lengths. Except this isn't that, because this is a lot older. We should look at the manual first and see when this thing first came out. It says nothing. Doesn't say copyright anywhere. So I'm just reading through it upside down for you. So the digital probe displays L when it's between 0.8 plus or minus, less than 0.8 plus or minus 2 volts. High is greater than, oh, it's when it's in TTL. Well, that makes sense then, doesn't it? What does P mean? P means transit. Okay, it's switching between those two. I guess you're supposed to actually get, with this set, a whole bunch of bits and pieces, or maybe that's just the internal bits. Could take it apart and have a look, I guess. Diagram, well, there you go. You can tell it's a bit old because it's got a diagram of an Apple II slot connector. So you wouldn't think that was number one on anything. It's an IBM PC slot connector, an IEEE 488. Well, that's a bit old school. Good if you have a Commodore PET computer. Memos and it's good that no one's put the memos in there. It makes me feel like it's better quality. So it's quite a cool thing to get. I did actually like it had a buy now when it was originally advertised, and I thought, no, I'm not going to do that. I'll wait. And then I actually think I ended up paying more than the buy now, but I was like, I really want this thing, so I'm going to get it. And so I plugged all those in. So well, I can't put them all. I'll put that one. Oh, there we go. It's got something. It's working. It says 7. Well, that's nice. And so if I take that one, oh, there we go. Once it gets going, it's fine. It says 3. So that one's a bit broken. So that's kind of cool. That works really nicely. Nice. And there's the switches. I don't know what there's little things I can't quite see because they're not from my view, but there you can connect those up and you can switch, and then you've got some buttons that you can detect if they're up or down, so that's nice. But yeah, I've only got 2 minutes left on the clock. Let's make an LED turn on. I'm assuming we have to put in a current limiting resistor, and these are pretty old school, so they're probably not going to light up with the 33K resistor. I think this one's 1000, so we'll put the 1000 one here with the 2 minutes left. So 1000 ohms should be fine, and then we can take this off. So we've got bored of that. So that will be fun. And then that one And so 1, 2, 3, 4, 5, 6. Well, let's just put it into 6. That one works, and it's that lovely sort of old school green. I like it. And they do show up, but they're not all the same intensity, are they? You can't actually see that, so I have to move the whole thing again. There we go. 1, 2, 3, 4, 5, 4, 5. I'm counting from 1 when it's counting from 0. They all do kind of work. I'm pretty sure when I bought this, it said on the instruction on the thing that one of the LEDs doesn't work, but they do appear to work. So that's quite cool as well. So much fun. So the ground, that's just the random. They just give you random grounds every so often, which makes sense. Yeah. But anyway, I hope that was interesting. That wasn't. I really did want to talk about these things. So these ones are neat because they're a bit of an odd shape. We've got like a minute left, so we'll talk about these for the next video. But I'm going to go back to the joysticks. I'm going to just find everything and work out what I did wrong. But these ones are 2 colors. These are green and red mixed together, and they're 8 by 5. But I've got 18 of them, so I should be able to make something. So I figured if I put 3 of them together and control them with a whole bunch of my idea is to use 4017s and the 74 HC595s. Not going to use proper controller chip because I want to do it the hard way. But if I put 3 of those together, that should make a sufficiently long enough screen to make a simple game of Tetris. But anyway, that was cool. I'll take it apart one day, but not today because I don't want to. Because I like it too much. Okay, bye!